Okay, algebra students, it's time for us to do our next lesson. We are still in section 2-4. This is just the second day that we're working on it. And we still are working with equations that have variables on both sides of the equal sign. But now we're going to talk about something called an identity and something that has no solutions. So today I'd like for you to be able to identify the types of equations that are going to have no solution at all, or if they are an identity. So here is our first question, and it says, what happens when the amount of the variable is the same on both sides and or the variable disappears in the process of solving for it? So the important thing here that I want you to notice is that the amount of variables is the same on both sides. That's pretty valuable right there. So what's going to happen if these things cancel each other out? Well, let's look at an example. Here we have 2x plus 6 equals 2x plus 6. So I want to get my variables together. So I'm going to subtract 2x from either side, and then I get 6 equals 6. Okay, well, yeah, that's true. So I'm just going to put a check mark beside that because, yes, 6 does equal 6. Over here, I have negative 13y plus 0, so I'm just going to get rid of that, is equal to negative 8y minus 5y. Well, negative 8 minus 5 is negative 13. And if I try to get my variables all together, I add 13y to either side, and I get 0 is equal to 0. Well, yeah, that's true as well. These are something special. When you get an equation where the left is exactly the same as the right and everything works, your solution is all real numbers. So basically all we're saying is no matter what number you put in, it could be 1/2 or negative 100 or 25. It's going to balance this equation because the equation has an infinite amount of solutions. So when it is the same number on the left and right, such as 3 equals 3 or negative 4 equals negative 4, and so on and so forth, the solution is all real numbers. A short way that we can write that so you don't have to write out those words, this is called a script R. So it's just 2 lines for the upper part, and then your curvy R section is just 1 line. Now there is another way that these special equations or special situations could come out. You could get something where that's not the same number on both sides, like 1 equals 2 or 5 equals 7 or negative 3 equals negative 4. Well, we know that 1 does not equal 2 or negative 3 does not equal negative 4. So if that's the situation, then the solution is going to be no solution. It's impossible to solve the equation, or to balance the equation, I should say, because it is imbalanced ahead of time. If you want to say no solution in shorthand, then you can put a 0 with a big slash through it, and that also means no solution. So what we're going to do with the rest of our examples, we are going to work through them and see if we're going to get an identity, which an identity is where you have the same number on both sides, or if we're going to get no solution. So let's look at this first one. Remember what we talked about in previous lessons. If we have parentheses, then we should go ahead and get rid of them. So I'm going to distribute that 2, and now I'm going to rewrite my equation. So I have 10x minus 6 is equal to 2 times 5x is 10x plus 2 times 3 is 6 minus 12. So all I did was rewrite with my distribution. Now I'm going to combine like terms. Notice I have a term right here and a term right here that I can combine. So I have 10x minus 6 on the left is equal to 10x. 6 minus 12 is negative 6 or minus 6. Remember, a minus sign and a negative sign are almost interchangeable. Are they a little bit different? Yes, but in general, you can just about interchange them. Okay, now I'm going to get my variables all to one side, so I'm going to subtract 10x from either side. So those cancel on left and right, and I have negative 6 is equal to negative 6. Notice that this is the same number. So I know that it balances, which means my solution is all real numbers. But once again, if you just want to write R like that, then you can do that as well, and I'll know exactly what you mean. Okay, let's look at another example now. It says, solve 2x plus 7 is equal to negative, and then quantity 3 minus 2x. Okay, so there's nothing I can do on the left side, but I can do something with this negative. Remember, there's an invisible 1 right here, so if that helps you, then you can write it in. This negative 1 needs to be distributed across the parentheses. So I'm going to rewrite this now. I have 2x plus 7 is equal to, this becomes negative 3, and then negative 1 times negative 2x is plus 2x. Okay, now I'm going to get my x's all together, so I'm going to subtract 2x from either side. They cancel, because 2x minus 2x is 0, they go away, and I have 7 is equal to negative 3. Well, you guys know that 7 does not equal negative 3, so this is going to be no solutions, like that. So the process is still the same. We're still distributing, combining like terms, getting our variables all to one side. It's just now we have some special cases where we might get kind of interesting answers, but it's very similar to what we did in previous notes. Okay, we have another example, and this one's kind of lengthy. We have an exponent in there. Don't let it scare you. Just take it one step at a time. So I have negative 4 squared plus 5m minus 4 is equal to 2m plus 3m plus 2 times 6. The first thing I'm going to do is simplify any numbers that I can. So negative 4 squared, that means negative 4 times negative 4, like this. So a negative times a negative gets me a positive. So I have 16 plus 5m minus 4 is equal to, and I'm going to go ahead and combine these like terms. I see 2m plus 3m, so that gets me 5m. And then I'm going to multiply this 2 by the 6 as well, so plus 12. Now I have some more like terms on the left side of the equation. You can see it here. I have a positive 16, and remember, you are not paying attention to the sign behind the term. It's not 16 plus and then this number. It's 16 minus 4. So I'm going to get 12 plus 5m is equal to 5m plus 12. Okay, get my variables all together, so I'm going to subtract 5m from either side. I'm subtracting because subtraction is what's going to get rid of a positive or an addition. They happen to cancel, and I get 12 is equal to 12. Well, that does balance, so we are going to say all real numbers for our solution. For our last example, I want you to make some of your own examples of an equation that will have no solutions and an equation that will have all real numbers. I will go ahead and show you a couple of them. So an example of something that has no solutions might be like 2x plus 5 is equal to 2x minus 10. Notice how I have the same amount of variables on either side, but a different number. So that's how I automatically know it's going to be no solutions. Another example of no solutions could be 3 times the quantity of x minus 4 is equal to 3x plus 7. Well, here, if I were to distribute on the left side, I'd get 3x minus 12 is equal to 3x plus 7. So once again, I have the same amount of variables, but a different amount of constants or numbers. So I would like for you to make your own example of no solutions. After that, we're going to do examples of all real numbers. So this would be a case where you have the same amount of variables and the same amount of numbers. So an example might be 4y minus 8 is equal to 4y minus 8. It's exactly the same on both sides. You can get a little creative though. You can also do something like negative 2 plus k. So this is negative 2 plus 2k, because that's what happens when these two combine, is equal to 2 times the parenthesis of k minus 1. So when I distribute my right side and combine like terms on my left, I'm going to get the same exact equation on my left and right sides. So that means I'm going to have all real numbers for my answer. I'd like for you to make a couple of your own examples, and when you're done with the notes for today. Have a good night.